Good evening to Poland. Good morning to the US. It's a great pleasure for me to have the opportunity to speak as a woman in machine learning and data science. And today my topic is about the machine learning and GenAI application in the entertainment world. And we're gonna start from embeddings. A few words about myself. I'm Neil. I'm a data scientist at Fandom, and it's a surely great honor for me to have Fandom as my first full-time job ever. I have completely business background all the way until 2 years ago. So if anyone's interested in career transition to tech, I'm really happy to talk about it. And in my free time, I have a golden retriever. She's really picky about her food, like every day how to prepare her food and let her eat her food is one of the biggest tasks of my life, which I'm not very happy about it. And since we're here at the Fandom office, let me have a brief introduction about what is Fandom. So Fandom is where fans find their passions. The fans would create content about their favorite TV shows, movies, and games, interact with other fans, and join the community to celebrate their love. And because of that, we have more than 40 million pages created by fans, and that brings us around 350 million traffic globally each month. And by the way, if you're a fan of Star Wars, if you look up the Luke Skywalker on the Google, and the first searching results will be us. So Fandom is not Fandom as a website, it's actually Fandom family. We have other websites like Metacritic, GameSpot, and Fanatical, because we want to offer fans the most comprehensive experience for them, from getting to know a TV show and to know the trivia stories about the characters, and all the way to starting playing the spin-off games of a TV show and start writing reviews. And for us to deliver those comprehensive experiences as data science team, we use machine learning and GenAI to realize those promises. For example, if fans are interested in Harry Potter, should we recommend them the Lord of the Rings content as well? If Disney released a new movie and they're excited about putting advertisement about those, which page should we put those ads on? If fans are curious about, okay, which house did Harry Potter studying at Hogwarts? The answer would be Gryffindor, and we're gonna link the pages mentioning those answers to them. And also we want the users or fans to enjoy themselves or exploring all the fandom content. So those are our goals. We have more and more. But specifically today, I'm going to talk about embeddings, specifically the most straightforward, simplest application, which is embedding in the similarity search, and talk about how simple approach can also bring the huge business value. And for the second part, I'm also going to talk about what are the other machine learning and GenAI applications in the Fandom. So for embeddings, we have a lot of embedding-based projects and already implemented in production. But today I want to talk about the most recent project me and my team been working on over a 3-day period. Because I think it's a great example to indicating how simple approach can also bring the downstream huge business value. So what is the problem we're trying to solve here? As I mentioned before, Metacritic, it is one of the Fandom family. And it's a website which aggregate the reviews from both the professional critic side, and also the user side. As you can see from the screen, which is the game The Legend of Zelda, 9.1 is not bad. But there are almost 2,000 user reviews. What if, as a fan, I want to know just a certain aspect of the game? For example, what is the character build-up in the game? Should I just go through almost 2,000 user reviews just to see if anyone even mentioned of it? I don't think the experience will be too rewarding. So what do we want? What is the outcome that we want? So we want not only the aggregation of the user reviews, which we already have on the website, we also want the user reviews to be represented by the keywords that fans be interested in, for example, the character. And we want to summarize the general opinion of that aspect of the game. And when the user click on it, the users can show all the reviews that are mentioning that certain aspect of the game or TV or movie. And we call it as snippet review. So how exactly do we achieve that? Before I dive too deep into how exactly are we gonna implement the approaches to solve them, I'd love to introduce some basic concepts that serve as a framework to the exact implementation. So the first one is we have user reviews, we have the keywords fans are interested in, but the machines won't understand those words, right? So how do we convert the text to the numbers? And we're gonna use, there are several approaches, but from the top of that, machines are incapable of understanding words. As a human, if I say man, woman, dog, cat, but from the machine side, it's like, what are you talking about? So we need to transform the words into the numbers so the machines can understand. There are several approaches. The most straightforward one is, how about we just assign numbers to the letters? But the problem of it is that even though for a word, even though it has the same composition of the letters, but if the sequence is not the same, it means completely different things. For example, the listen and the silence. And also, this approach cannot capture the relationship between words. So it's kind of hard to get the results that we want. Then next level, how about we assign numbers to the words itself? For example, the paragraph you can see here is from A Tale of Two Cities from Charles Dickens. Considering this paragraph, all the words in it are all the vocabulary I know as a human being. So how to represent the first sentence is, if a word is inside of sentence, I'm gonna assign 1. But for the rest of the vocabularies that do not appear in the first sentence, I'm gonna assign 0. This is a great way, backup words, it's a great way to converting the text into words. It's successful in classifications, but the problem is that it still cannot capture the word relationships because a word can mean completely different things just based on the context. So is there any approach that can capture both semantic and syntactic features? And here we are as embeddings. And we're going to the next level because we're not only just assign one number to one word. We're going to assign a bunch of numbers to represent one word, like woman here. So how exactly does embedding work? For example, cities. We have San Francisco, we have Oakland. How, as a human being, how do we describe a city? We can describe it using the dimension of longitude and latitude. We can add another dimension like population. Furthermore, we can say what is the annual GDP, the average rental pricing for the housing, and etc., etc. So embeddings are using the multi-dimension to capture the meaning of the words. So how do we generate those multi-dimensions? And we use the neural network to do that. And the goal of training the neural network is to predict which words would occur together. And embeddings will be a byproduct of it. Specifically, for example, we have a sentence, the oak tree are ancient and huge. How do we train the model is by, one of the ways is by feeding the model the target words, which is trees, and then let the model to predict the rest of the words, which is the context. Specifically, In the input layer, we're gonna assign the target word as 1 for the rest of them as 0. And then go inside the hidden layer, which is where the embedding happens. Because the goal is to infer what are the context words here. The closer the context words that the model inferred closer to the reality, we're gonna say good job. If it's not close to reality, we're gonna use the error function and the back propagation to punish it. Just go back to work until you give me the result I'm satisfied. So in this way, if two words often occur with the same context words, the model has to produce the similar vectors for these words in order to achieve the high accuracy when predicting the context words. And by the way, I apologize if you hear any noise from my background. That's because my dog is playing with her balls. So here we already know how to convert the text numbers, but which neural network are we going to use to generate those embeddings? Our standard is by using the MTEB leaderboard on the Hugging Face. It is a massive benchmark for measuring the performance of the text embeddings throughout the 8 embedding tasks and covering a total of 58 data sets and 112 languages. And not only that, because in Fandom we use BERT for a lot of page classification projects already, and for the UAE-Large-V1, it is also the BERT large added with the angle. So we use BERT as the baseline, and the criteria will be what is the speeding of embedding calculations based on the size of the files, and also the speeding of storing into the vector database, also the speed of similarity. As a result, we have winner. UAE-Large-V1 performs way better than just BERT itself. So we have our tools to generate embeddings, but how do we find the similar ones? And because, as I mentioned before, similar words would have similar vectors because they have to achieve to predicting the similar context words. So in a multi-dimensional world, if vectors or dots here are close together, they're the similar ones. And the tool we use to find those similarity dots is the FAISS, which is Facebook AI Similarity Search. It is actually a standalone vector indices. It's not a vector DB, but it is optimized for fast similarity search in the large data sets. And it has GPU support. That's why we can use the EC2 machine for the quicker calculation. And for the exact similarity search method, we use the flat index, which means that we do not change anything about the vector itself, and we use the Euclidean distance, because there are other methods in the FAISS as well, which including clustering the vector first and then find the similar one. But we do not do that because accuracy is our priority. Even though it takes more time, we want that. So specifically, back to our cases. We have keywords that we want, like visuals, gameplay, or what is the real playability value. We're going to generate embeddings using the UAE-Large-V1. But as I mentioned before, we not only want the keywords, finding the similar keywords, we also want the keywords being summarized into the general opinion, which is positive, neutral, or negative. So how do we do that is that we divide the keywords into good ones and bad ones, and then generate embeddings for them. And for the user review side, there are 2 steps. The first step is generate embeddings for the whole user review. Like each of the user review, we generate each embeddings for them. The second of all, which is because we want to see which part in the user review that can represent a certain keyword. That's why we need to split the user review into sentences and then generate embeddings for them. So at this moment, we have the user review embeddings. We have the keywords embeddings. We're going to do the similarity search. For example, here at the red corner for this review, the matched keywords would be the good graphics, good music, and the bad difficulties. For each of the review in our data set, we would have matched keywords. And we're gonna aggregate all of those keywords together into, for example, graphics. There are more than 600 of reviews mentioning good part about them. So we're gonna say, okay, the graphics is positive, music is neutral, and difficulty is negative. Not only that, because we separate the user review into sentences and generate embeddings, that's why when we click on the keywords, we can say that what are all the snippet reviews that can represent a certain aspect of the keyword. And I have a product demo for us to have a more straightforward opinion about what it looks like. So I'm on the Metacritic. I'm a user interested in The Legend of Zelda. I can see the score, which is 9.1, not bad, but I want to know a certain aspect of a game. Let's say, what are the user reviews? When I click on it, there are almost 2,000 user reviews. It's too much. I don't want to go through all of them. So instead, I'm gonna scroll down to here. I'm interested in the gameplay. When I click on it, I can say, yes, most of them are positive. It's a good gameplay. I'm interested in single player too. And I can see all the reviews that I'm mentioning about this aspect. And this is the product demo. So for the impact, even though it's a simple approach, but it did bring a lot of impact because it increased the user engagement. The users can be more pleased when they're browsing the Metacritics and they click the aspect they're interested in. And it's also helpful as targeting. For example, if for a certain game, character build-up is really good, the positivity is really high. And if a certain game is promoting its game about its characters, then we can match them together. And also because we have the keywords, same example, if the character is really good, have positivity, and we can recommend from fandom side, what are the trivia stories about those characters? And link them together, which makes the cross-website recommendation possible. And for the next part, I'm going to talk about what are the other machine learning and GenAI applications happening in the fandom. We have, first of all, page classification. Because fandom has almost 40 million pages created by fans, it's very hard for us to manually to label whether a certain page is about a character or it's about the location in a certain movie. It's from a movie or from a game. What is the genre of it? It's medical or it's drama. It's very hard to do that just manually. So we use the machine learning model to do that, to identify the labels of the pages. And because we have all the labels available for the pages, that makes as targeting possible because we allow the advertisers can customize their targeted audience. If they want games, if they want the first-person shooter kind of games, we can do that by assigning the ads to those specific pages. In addition, we have GenAI quizzes. For example, here, how much do you know about 11? I think it's a very, very interesting quizzes. So we use the GenAI based on the fandom content. We generate the quizzes and the answers together for users to enjoy these small quizzes. It can drive the engagement without like requiring the users to create quizzes. For the fandom, even if we have the answers that the users been searching for, But sometimes if we search on Google, we're not on the top of the list. So that's why we want our own searching engine inside of the fandom. For example, the quick questions here, we can offer the users the briefed answer and also link the pages that are mentioned in those answers, which is more convenient for users to explore the whole fandom website. And another thing is, as I mentioned before, Fandom is a fandom family. We have multiple websites, but how do we combine those content together to give users the best experience? For example, in the fandom side, we have the Harry Potter wiki. And for the Harry Potter, it not only is just books, it not only just a movie series, it's also a game called the Hogwarts Legacy. So how do we recommend the game to the Harry Potter fan on the fandom as well? And also let them to know what are the reviews about the game, reviews about the movies as well. So how do we do that is that we use the GenAI to generate the franchise. And we link the franchise together, let the users to enjoy all of the content inside of the universe. Takeaways for today. Machine learning GenAI makes a lot of impact at Fandom. For example, the ads targeting, the quizzes, the search engine, and across website services. But sometimes simple and a quick approach like embeddings in similarity search can also make huge differences. And please visit fandom.com if you like us. And kudos to Yulia and Martina. Thank you so much for organizing everything and promoting on the social media as well. And also kudos to my DS team. Without them, none of the project would come to realize. They are Abar, Jay, Jacob, Sahar, and Flo.